Thank you very much. Thanks, everyone, and welcome to everyone trickling in. Yes, the 5 dimensions/demons of Python packaging. I think I have something like 45 slides in 30 minutes, so God help us all, but we'll get through it. So if you want to follow me, I'm trying to move off of Twitter onto Blue Sky, so I have my Blue Sky as well as my Twitter up there. And so I just want to actually contextualize. The point of this talk is actually not to advocate for any particular tool or against other things. What I've noticed over the last several years of discussions around Python packaging is that many times people talk past each other, because everyone's coming from their own perspective, everyone's coming from their particular pains they're trying to solve. And actually the Python ecosystem is so large, and there's so many different kinds of problems people run into, that it's very easy for us to talk past each other. But the thing I think we can all agree on is that Python packaging just sucks. Like it's so, like, why is it always so terrible? And that's why the long form title for my talk was that fuel our persistent nightmare. Why is this nightmare persistent? Why are we always in pain? What's hurting us? And the point of this talk is to try to give us at least the tools, the framing, the basis vectors to use to talk about why packaging is hard in Python. And I do have a thesis as well in it. But before that, there are trigger warnings, right? If you've ever had subnormals get squashed, if you've ever run into torch build errors because Intel deleted a symbol in a shared library, if you've ever had to run into SSL digest algorithm issues, or if you've ever had to go and actually, God forbid, build Python and build OpenSSL with its glorious 3,000 lines of Perl configure script, this talk is going to cause you to convulse. And of course, if you've ever accidentally gone and fixed a Valgrind issue by squashing entropy in OpenSSL, this will definitely give you trigger warnings. So back to our original question, why does Python packaging suck, right? Well, software packaging at scale is always hard. It always kind of sucks. How many of you maintain a Linux distro or do anything like this in the package management space? Anything? Very few people do this. It's thankless work. It's always hard, right? And in Python in particular, Python gloriously is a cross-platform language. It's actually cross-architecture. If you ever do any embedded work, if you work on ARM chips, which all of you with Macs, you have an ARM-based chip. If you work on x86 chips, right, you have a cross-platform, cross-architecture computational environment. So cross-platform packaging is particularly hard. And we also, the reason why Python packaging is so hard compared to other languages is because we're at the intersection of multiple different unique challenges. And that is really the scope of this talk, is to get everyone at least the basic tools to understand what are all these different dimensions of pain. And a visual I like people to think about is this cover of Gödel, Escher, Bach, right? Depending which angle you're looking at it from, the same fundamental higher dimensional object projects into your space as a G or an E or a B. And so the next time you run to somebody who is like, wait, just use poetry, but you're a Conda person, or you're excited about UV and you don't understand why people are working on Hatch, it's because we're all groping around this multidimensional object, right? And that's the point of this. But before we do any of this, let's first understand what is packaging. Why do we package anything? Ultimately, I think there's just really a few core motivations for packaging, and that generally is code reuse. We want to share code with someone else in collaboration, or we want to reuse it ourselves. We want to extract something that, extract and abstract something that we might reuse later. There's deployment. We have a development environment, and we have a deployment environment, and we want to take just the bits that are needed to run deployment. And of course, there's preservation, which is really, really important. If you want to have reproducible workflows, if you want to be able to go back in time and see why did this work yesterday but not today, this is all very, very important stuff. And I think one of the most insightful talks around packaging actually comes from PyBay's very own Mahmoud Hashemi, who gave this talk, The Packaging Gradient, many, many years ago. And I still find it to be one of the most insightful talks about this topic. And he says basically, look, what you need to package something in your own personal life, if you pack something for a trip, it depends how far you're going, right? If you're just going a few blocks, you just need a purse or a wallet. If you're going to another country, you're going to have to bring some more stuff, right? And it also depends on, there he is right there, look at that. And ultimately, there's a really beautiful image, which is, the distance and the accommodations determine what you want to pack. So do you need a suitcase or a Winnebago, right? And there's a lot, it's a wonderful talk. I encourage everyone to go revisit it if you've never seen it, or if you haven't seen it, go look for it. If you've seen it before, revisit it to really kind of go through this articulation that depending on what you're trying to do, packaging for you could just be SCP or CP even. You have your own dev environment, you've got your own Python, you've got your own packages, you copy a file that works. Python is brilliantly simple and elegant. Here's a .py file, now it's in a different directory, it still runs. Great, I've deployed, I've packaged, it's great, right? But if you want to actually have this thing work on somebody else's machine with a different architecture, with a vastly different set of underlying libraries, good luck and Godspeed. So the difference ultimately here between the dev environment and the runtime environment, that determines the scope of your packaging problem. And here's the interesting thing. Most modern web devs that deploy to VMs and containers are doing it, those are under their control. Even if it ships into production, and even some production stakeholders are telling you what can and cannot be in it, for the most part, you are actually deploying to yourself. The people who suffer packaging problems the most are people who are writing libraries. The maintainers of libraries have to run on lots of other people's machines. And that is just where all the pain starts. Let's visit our first daemon. What is our first daemon? It is native extensions, right? This is really at the heart of one of the things that hurt us. And this is actually also one of our strengths. So the reason that Python is such a popular language is because the VM is quite simple. The C Python VM has a lot of simple hooks, a lot of simple ways to connect it to C and to C++. That's why we can have things like NumPy, right? And so it gives us all of this great power, but then we inherit all of the horrors of the last 50 years of the entire C and GCC and Clang and LD and ELF and Mach-O and framework builds and all of that nonsense, right? So because we tie into the ancient powers of the rings forged in the days of old, we also get a lot of the shadows that come with that. It's long shadow of the 70s, I like to call it. And for those of you who don't recognize the right, that's the Kowloon walled city, which is the stacks and stacks of houses that just kind of happen to not fall, and they build more things on top of them. So here's the thing. If you ever try to compile something, actually compiling something is very hard. And if you try to compile someone else's code, it goes even beyond hard, right? At the end of the day, the build environment matters tremendously. So we talk about packaging. Packaging is, yes, it's hard on its own. But man, trying to have a regularized, rationalized, normalized, and well-understood build environment is damn near impossible. And before anyone tells me, oh, just use Nix, or just use one of these verifiable builds on the blockchain, or one of these other things, keep in mind that for security reasons, sometimes you want and you need randomization. So just think about that for a second. You want randomization, and you want reproducibility. Good luck. But ultimately, the harder dependencies, the runtime environment explosion, new kinds of chips coming out, everyone wanting to use GPUs at training time and inference time, all of these things are just going to make this problem harder, not simpler. And at the end of the day, the big challenge is that normal people just want this to work, right? Like Melania Trump, they just don't care, right? And by the way, this, on the record, this is the first time I've ever quoted Melania Trump in a slide presentation. So for instance, to give you a sense of the scope of this problem, again, trigger warning. These are all real things that our build engineers have to deal with at Anaconda. For me, I think it's a toss-up, which is the most insane. I think it's the first that some packages build differently depending on the date. But maybe it's the fact that sometimes third-party binaries that you don't have the source code for will nuke symbols without telling you. But in any case, or maybe it's the Windows max path length. Even the Windows documentation varies on whether that 32767 is a hard limit or it's an ish kind of limit. So this is the kind of stuff you run into. And you're like, well, why does that matter? Why do I care about Windows path length? If you ship a library to somebody, I don't care if it's a conda package or a wheel, you give it to somebody, they create a virtual env, they have a long name that happens to expand Unicode-wise into some other characters, and you unzip. You try to unzip that zip file into a virtual env, into libsci packages. Boom, all of a sudden, some of the files can't be extracted. So these are the kinds of things which you yourself may never run into, but as a library maintainer, these things bite you all the time, right? And we just have hundreds of thousands of libraries in our ecosystem, not just the Python ones, but the C dependencies underneath that all have this kind of characteristic to them. So anyway, it's just a dumpster fire, right? It's a dumpster fire. And sometimes people, will glibly say, well, what packaging problem do we have? Like, what is the packaging problem? Because all I do is I just use RPM, and this is fine. If you can use RPM, that's great, right? If you're a Gentoo guy, you're like, emerge, this is great. But the problem is each one of these does something slightly different. And if you try to support other people, or if you try to build a library and try to give it to someone else, and they're doing these things, you have no control over what that deployment environment looks like that you're shipping that code to. And so I gave a talk actually here in the Bay Area many years ago, and I had this slide up. This, again, another trigger warning for people who've been through this nonsense. This is the build up to 2012, by the way. This is what we were dealing with through the ages of trying to build SciPy, trying to build NumPy, trying to ship a pile of stuff, of Fortran and other kinds of things, right? And so the SciPy project is filled with people who just have, I think they've now transcended to a different plane. But that's actually the origin of condas. In 2012, we had a PyData meetup, the first one down at the Google headquarters in Mountain View, and we, Guido stopped by and we talked to him, and he said, "Look, guys, your packaging problems may just be too exotic. The SciPy people, you just do your own thing, and that's actually why we created conda, like we're told to." But actually, for those who are not familiar, one of the most fundamental differences between conda and wheel is ultimately how we treat, what we see the tool as being and how we treat these native extensions. And so conda, because it comes from the scientific Python ecosystem, has always seen itself as a multi-language packaging tool. We've always known we need to target multiple architectures and multiple kinds of operating systems. And we've always known that we had to install into user land, because many people on Windows do not have root privileges to install into whatever kind of places. So we have to build all these packages to be relocatable and installable without root permissions. And this does actually matter a lot more when you have native extensions you depend on. But even if you're web devs, even if you're like, I don't touch any of this like data science crap, you depend on SSL libraries. You depend on accelerated image libraries if you want to do image transformations. There's a lot of stuff underneath the hood that you want to depend on that you really don't want to own the build process for. And so for us to think about what the future of packaging looks like, we really want to understand what does the convergence of all these tools look like. We really have to face this problem. And that's just part of it. How do you actually handle the native dependencies? And if someone says, well, we're not thinking about that, well, then they're not going to be able to solve the Python packaging problem. So our second daemon. And this is kind of a subtle one, but as the founder of Anaconda, it's one that I've had to live through for many years. And that is that there's a difference between a site that hosts bits and a repository and a distribution. These are actually very, very different things. And I've thought long and hard about how to articulate this, so I just created a table. Right? So if you just want to host bits, it's a Dropbox, an FTP site, everyone can do it. If you want to serve the right bits, though, by name, now all of a sudden someone's got to take an opinion on what is the name of a thing. All right? And this is harder than you think. It's more subtle than you think. Then you also have to secure the bits. Let's not even talk about that. Because secure from what? Securing isn't just keeping people from attacking it. Securing is updating it when it's been revealed to have a 0 day. And what are your guarantees? And what are your preventions from people suppressing your notification of an update, et cetera, et cetera? Then, another fun one, verifying the authenticity of the uploaders. That's a whole other pile of God knows what. And then ensuring the compatibility of all the packages that have been uploaded. And this is variable, right? Because sometimes, some people try to collaborate. Other times, it's like, whatever, YOLO, right? Caveat emptor. And of course, the last part, man, that is no bueno, right? Nobody really wants to think about how do we ensure the same build tool chain for all this stuff. And this matters, again, if you think back to the previous slide, which build tool you use can dramatically change the output. So, for instance, the CondaForge community and the Anaconda default builds, we have discussions all the time about what pieces do we actually standardize on, what pieces is there more flexibility on. That's the stuff that is not sexy, not interesting, but that is just fundamentally important if you actually want to have anything be compatible in this space. And so the question of who ensures what is the distinction between these different concepts, right? And that inter-package dependency conflicts, that's not just a weird NumPy, SciPy, PyData thing. That happened to Pydantic and Fast API earlier in the year, I believe, right? So these are the kinds of things that are ecosystem level things. And if you see something like PyPI as a repository for anyone to upload anything at any point in time, then the PyPI folks cannot possibly ensure or guarantee any kind of consistency. But then the tool like the pip folks or UV or Poetry, none of them can assure that either. So whose job is it? Well, then it becomes the user's job. And that's why even in the Python docs on packaging, it talks about self-integrators. Because the repository is not going to guarantee it for you. The library maintainers, they can only guarantee some of the packages they know about, but they can't guarantee all of it. So it's on you, right? So this idea of, well, the dependency problem, okay, maybe I don't have that many packages, maybe I don't worry about it. But if you really start worrying about it, if you really want many people to have a simple experience, you run into NP complete problems, right? And the little diagram on the right is just a little DAG representation of, I think, a few simple packages. I forget, it was like 3 or 4 packages if you try to install them, the giant explosion of interdependencies. And which ones you should install at what time is NP complete. So any tool that doesn't currently have a dependency solver in it and says, well, we'll solve that problem later, yeah, you will. So these, and the interesting thing is these are actual technical labor. Actually ensuring and dealing with typo squatting takes real people with real heart and also real technical chops to go and do that, right? Resolving these like conflicts and version numbers and making sure all these downstream packages work. That's real technical labor. So these are critical to the ecosystem we want to continue to work and to be adopted. And the really horrible thing that we learned this year is that our entire ecosystem, our way of life, is under attack by state-level actors who are not just attacking it like in some interesting, weird ways. They're attacking it, taking advantage of the burnout of maintainers. That level of social engineering should put everyone on notice. And if one state-level actor is doing this, I can guarantee you there's 100 others. So we actually have to look at this not just as a nice to have, but as something that we structurally, existentially have to fix as an open source ecosystem if we're going to continue having an open source ecosystem. That isn't just big corporate open source projects that land like a thud and have corporate security teams governing their release cycles. Right? It's existentially critical for our open source ecosystem community. All right. Progressing on this happy discussion, our third daemon. And this might be a weird one for people to see, but Python doesn't actually have apps. I don't know if you guys realize this, but you're like, what does that, wait, Peter, what does that mean? There's really not a reliable way to ship installable applications in Python that works out of the box. I know Russell's right there, Beware project, and there's like PyInstaller, PyApp, PyDXC. There's many projects that have made valiant efforts in this direction, but let's be honest, this is not how most people in Python land deliver their software deliverables. And has never been an out-of-the-box thing. I mean, tkinter, I think, was the last sort of like core blessed way of building a UI thing that you ship and then you can definitely run on someone else's machine. So the web dev-centric world for Python has really meant that people are really deploying to themselves, right? Most people are shipping to themselves. And if you actually want to publish software, you've got to actually do it to other user configurations. So the question really is, what does it mean to ship? And when we have these conversations, again, the point of this talk is to give people tools so the next time they're in the packaging discussion, that's something to reach for. So someone says, well, I just do this. You know, I just put things in a container. I put my Winnebago in a container, and that container is another container, and the whole thing just works. Well, you're shipping to yourself, so, you know, kudos to you, Einstein. But, like, what if you actually have to ship to someone who's not you? What do you do? So that's just the third daemon. But I just want to put that out there to keep in mind that people are shipping services, but they're really shipping to they're shipping software to themselves. Fourth daemon, and this is a kind of subtle one, and I don't have all the time today to get into the details of it. This is maybe another talk I'd like to develop. And maybe a path forward through this, but packages are not interfaces, and SDKs aren't runtimes, right? So package interfaces, what does that mean? Well, what is NumPy, right? Is it a collection of C routines with a thin Python wrapper? Is it a Python API for an array matrix computing? That's how most users of NumPy experience it. But many library developers who use NumPy experience it as a C API for structured access to system memory. That's a really cool power of NumPy. Or is it just something I don't even think about because I really just want to use scikit-learn, and I got this like NumPy crap on the back end, right? So and the answer is yes, it's all of these things. It's all of these things. So NumPy is actually an SDK, a software development kit or toolkit. And in general, when we think about a Python package, what is a Python package? It's actually an SDK for the most part. It's a collection of APIs that you might use while you're developing. But what's a runtime? A runtime is what you need to actually run your app. Very few of you, I would imagine, have ever written an app that uses 100% of the APIs of any of the libraries you're depending on. Right? Now, we don't have, because we have such a dynamical import system in Python, and there's execution runtime level dependencies on things sometimes. I mean, heck, if you use Jupyter Notebook, you can import anything you want at runtime, right? So we don't actually have a consistent way to do tree pruning on dependencies the way that you would in a statically typed language that has an explicit compile and link step. So in the Python world, we've just sort of gotten away with this, that we just ship and bundle SDKs with our app scripts, and that just runs. So we're in this mode, we've almost just expected that we should always be in the business of shipping SDKs. And here's the problem. The more powerful SDKs become, the more features they add, the more people want this encoding, this codec, or that particular algorithm that needs this weird Fortran module. Whatever it might be, as more stuff comes in, these SDKs have more and more conflicts with each other. Even if you never use any of those functions that clobber each other. So we have normalized the shipping of SDKs, and this dramatically increases our packaging dependency resolution conflict problem. This is one of the big pains, and it's almost impossible to see unless you really take a step back and say, wait, why are we doing this? And the origin of this thought was when I was reading Armin's blog post on Rye earlier in the year, and he was showing how, oh, Cargo does this great thing, and NPM does that other great thing. And I'm looking at the tree, and I'm like, why do you have 5 versions of this transitive dependency? There's no way you're passing some object from version 1.2 to version 1.4 and hope for that to work, right? Well, it's all these things get vendored in. They get wrapped up. And those things, there's just not, these things don't actually cross these boundaries. And in our case, we can't quite do that because we link to C libraries, and your process, your operating system will not let you pull in multiple libraries with the same name. So we actually have a harder problem because we have, again, the first daemon, the extension modules. But if we're able to actually change how we do Python, right? Again, the reason why all this works, by the way, is because, again, we put Winnebagos in containers. But to actually solve this problem, there's a weird out there thought I've had around how we can redo the concept of modules and imports and APIs so that in Python we actually have an explicit concept of an interface. We could then actually create a tree-shaken, minified API to actually ship as part of the runtime. And that doesn't exist yet, and it's something that I would love to work on with people if folks are interested in that, but that's beyond the scope of this talk. The 5th daemon, and the last one, and I would say possibly the most important one, is that we have a huge and diverse and growing community of users. So our greatest strength is also our greatest weakness in the area. We have so many different tribes, whether you're doing web dev, whether you're doing embedded stuff on a CircuitPython, a Raspberry Pi, whether you're in Excel, right? That's, actually blame me for that, but like, we're gonna have a lot of Excel users being like, I can't do this thing with I pip install something into my Excel formula bar. Okay, but the thing is, each of them, these ecosystems of tribes have their own like needs and goals, and they're sometimes quite incomprehensible to each other. So when we have new people coming into the ecosystem, and if we keep growing the Python ecosystem, there will be lots and lots of new people. There's some things they always need, like collaboration. There's some easy starting points. They don't have to learn all. They don't have to. A lot of people don't really want to know even how to use the command line to use Python. They certainly are never going to make it there with a Docker file, but they have this need to get some of these pieces in to use the rich library ecosystem in Python. And so there's lots of ways to do it wrong. There's lots of blog posts that say just do this, just do that, right? And the problem is that experts in one tribe can be completely wrong for the other tribe. So I'll give you an example. Here's a table. And I can tell you why both the recommendations on the left are right, and I can also tell you why the recommendations on the right are right. But they're just completely different and contingent on who you're talking to. Yeah, I mean, that's just like, okay, what do we do when both things are true, right? And it's, again, not just Winnebagos and Dockers. And the thing to be aware of, again, in the spirit of giving people tools to talk about the Python packaging nightmare that we have, the thing to recognize that Python has crossed the chasm, right? I mean, I remember my first PyCon was in 2005, and it was at the, not Georgetown University, but it was in Washington, D.C., and the entire Python community, core community, sort of fit in one auditorium at that time. I seem to recall Philip Eby was just building like setup tools at the time. And that was when we're over here, maybe we'll call ourselves innovators, but whatever we were not the mainstream. And once you cross the chasm into the mainstream, you have sort of a runaway problem in that people don't necessarily even know how to self-service to find the best ideas. They don't know what they don't know. They look to peers and they look to each other to figure out kind of what is good and what should we use and what not. And this is like okay if you're innovators or early adopters who can make sense of the world, whose sense making is based in the substantive aspects of the problem. But when you get to the chasm, it's a lot of peer signaling and it's a lot of vibes, a lot of these kinds of things, which, whatever, maybe that's an okay thing. But when it comes to technology, that's actually kind of problematic. And actually just recently, Linus Torvalds, right, had this thing about there are like hip trends that happen in tech, and that's not a good thing. Yeah, you want to be able to develop the tools to make sense of the technical landscape for yourselves. So I don't really have a solution here. I just want to drive the awareness that, if you talk to someone who has been doing Python for more than 5 years, they're going to have that's a very different kind of person with very different capacity to use tools and understand what might work and what might break than someone who's only been doing it for a year. And the people who've been doing it 5 years don't know the things that happened 10 years prior to that, right? So the gentle reminders here are just when we have online discourse, when we're talking about, oh, this tool, this thing, that thing, not all Python programmers are actually software developers. How many people here actually are software engineers? You get paid to ship code. How many people? All right. So there's a lot of folks, if you go to the data conferences, you go to the AI places, they're using Python. They're stubbing their toes on Python packaging issues left and right and center, but they're not actually software developers. Like, wow, that's amazing. But think about it. They're in a notebook. They're in a Jupyter notebook. They're slinging a bunch of code. They've got some SQL they're pulling stuff in from. They're not software engineers. They don't really know how to debug operating system DevOps level kinds of problems either. And also, by the way, Windows exists. I mean, Windows is a thing. I know we're in San Francisco, but Windows is a thing. 90-something plus corporate machines are running Windows. So if you're one of these open source devs who's on a Mac shipping to Linux, and you put in your GitHub repo, like, I don't care, Windows users can solve their own problems, okay, but recognize that's a huge amount of the corporate use that is going to be paying people salaries that are Pythonistas, right? And a fun fact, the initial, when IPython Notebook, the web notebook first came out, their approach for handling, this is not to shame any of those people. I mean, we were a tight-knit community at the time and people didn't have time, but their approach for shipping Jupyter Notebook or IPython Notebook to Windows was to ship a Linux VM. Like VMware, just use VMware Fusion, it's, the runtime thing is free, and you can just run the Linux VM. And then my question was, well, how are these Windows users going to use the Linux command line? Like this is, this is the kind of thing that we have to get around, like just recognize the community is very diverse. And just because something works for you doesn't mean it'll work for others. And just because something broke for you doesn't mean that it's a wrong solution for others. So when we talk about this complex landscape, again, back to the Gödel-Escher-Bach thing, you may only have 2 or 3 dimensional sub-projection of the landscape. So just be humble and be clear about what your assumptions are and whatnot. And because I'm the last thing between you and lunch, and I'm not going to be screwing over another speaker, I'll just be screwing over all of you in your lunch, I will add a 6th daemon as a bonus lanyap daemon. It's a little baby daemon. It's one I am seeing now, though, which is really interesting, which is, and this has come to light quite a bit, actually. I was surprised at PyCon and then just recently as well. There is like, so how many people have used UV? People played with UV a little bit? How many people like it? Yes? Good, maybe, yeah. UV's cool. I think it's a really cool thing that Charlie Marsh at Astral is doing this kind of thing. But in the discussions around this stuff, there's like all this, that's the monopoly guy that I put him on there. But there's like this shade thrown at him because he's got VC backing. And I find that kind of interesting, right? Because when we think about the Python community, the ecosystem, we talk about maintainer burnout all the time. Actually, let's say, so Jacob had this nice blog post from a while ago about the impossibility of this, where we insist on people doing really great work, we are concerned about their burnout, and almost every route of monetization is sort of, it's vibe checked for various reasons. And so I think if we want to go back and think about, going back to this idea that to have working package repositories, to actually have working, secure Python package repositories like PyPI or CondaForge or whatever, these are the kinds of things that take real technical effort and labor, which is not free. And so if we want those things to be sustainably financed, we want innovation in the space to not just come from the generosity and benevolence of huge trillion-dollar corporations, then as a community, we actually should be supporting people who are doing these kinds of things, supporting entrepreneurship in this way. And I think about, it's not just, I mean, Charlie's a nice guy. I think he's been very, very, very nice and engaging on these kind of topics. What I think about a little bit is the chilling factor of anyone else is thinking about doing their own, taking their tool that they made and trying to build a business around it or trying to figure out ways to commercialize it and engage in the community. If even something, that's well-loved like Rough and, a tool like UV that's got great promise, if this is the kind of reception they get when they come out the door. And I know what some of you are going to say. It's like, well, Peter, you and Charlie might just be part of this, like, part of the big Python packaging mafia, right? All of you are trying to commercialize Python packages. We know how you guys, we have the secret, actually we have our mafia meeting in like, I think a month. So I'll be very transparent because the question is asked, how does he make money? I don't know how he can make money. I think it's like, he doesn't have a business model. I expect it to implode. Like, that's not a very nice thing to say about someone's business that they're putting their, nights and weekends into. And so I'll be very transparent. Here's how Anaconda makes money, is that if you remember that chart about what's hard about all these things, there's a few other, there's not just a few, there's a lot of other additional things that you can do as a distribution, as a commercially ready and vendor-backed and vendor-supported distribution that are extremely valuable to businesses. And that's what we do. We sell, so it's all that column over there that we do. And that's the same as what Red Hat does, as Ubuntu and Canonical do. It's a tried and true sort of business model around this stuff. But this is the kind of thing that can then yield benefits, right, to the overall community, as we're able to then take the revenues from here and invest them back in things like the community repositories like CondaForge, or into next generation packaging tools that we might be able to develop. Obviously, we'll be developing them in the open with everyone. So this last daemon is just, why do we insist on a vow of poverty, right? Is that actually Pythonic? And so if it is useful, if Python is useful, if the ecosystem is useful, if there are hard problems that businesses want us to solve, let's make some damn money doing those things. That's actually okay, as long as the people who are, as long as when we do it, we are committed to the values of the community and we're reinvesting back in this stuff. This is a beautiful path for sustainability, right? And so if we don't do this, there is also a dark side, which is right now Python is, a lot of people are showing up with PyCon, a lot of big companies are showing up with PyCon with big checks, and that's all great. We want them to support the community. But what if, what if our day in the sun goes away? What happens then, right? What if if some other language shows up and takes all of the energy from the AI space? What if it's Java or C++? If they come around, or it's Mojo, like all these things could go and cause some of this sunlight to fade. And so if we actually want to support corporate adoption of Python and keep those dollars sustainable, we should be encouraging more entrepreneurship that is of the ecosystem and that is sustainably in the ecosystem. So in conclusion, here are the 5 dimensions of our packaging problems. Some of them a little obscure, some of them are pretty obvious, but when you find yourself next time in a packaging discussion, think about what actual problem a person is talking about. When they propose a solution, think about what that solution solves and also what it doesn't solve, and at least have an understanding of this kind of multidimensional nature. Now, all of this is very, very depressing, I guess, a little bit, this talk, but I do want to end in a really, hopefully in somewhat of a positive light, which is that these packaging problems that we have in Python land are unique because we have so many dimensions, a way that Rust and Node don't have. That's why Python is the language for AI. That's why Python people can get jobs doing data stuff and doing AI things. All these are very, very powerful for Python, but that's also the source, that's the cause and the consequence, right, of our success. And so the community that we have now has many, many needs, wildly divergent, different kinds of environments that they're running in, all these kinds of things. So I would just, caution people from looking for silver bullets. I would caution people against thinking that this is just, if we just did X, this would solve the problem. We're really not going to be able to do that. What we're doing is something that actually C never managed to do, and that C++ never managed to do, and that Java never managed to do. We are really in uncharted waters here, because there's not a lot of newbies coming out of grad school who can go and write C++ code on a distributed system, run it in production on data that's being pulled out of SQL with high-level code that's written in C. Like, you just don't do that with C or C++. Python, people do that every single day, right? So we have achieved something incredible with Python, and that is actually the source of our pain. And that's really the goal of this talk, is to give people a sense of just the breadth and the span of the problem we have and how unique it is, and then we have to find our own way through this problem. Thank you.
So there might be a 7th demon, and that is the temptation for lunch. But we'll leave it open for Q&A. We've got all the time for those who want to stay here.
Yeah, I was very interested in the 4th daemon because I maintain some Python packages myself, and they have like optional features, and I'm like, okay, how can I like make these dependencies, manageable? And then I've also seen fast APIs been going back and forth between what to put in its core and what to put in extras.
Exactly.
So what are your thoughts on extras? Should we use extras more, or do you think there's a better way?
I don't have any thoughts on extras in particular. I do think, well, sorry, let me take that back. Let me answer your question. Yes. Actually, the architecture that would be ideal, and that when you see large packages, what ends up happening is that they do end up with a core set that almost everything will use, and then there's these extras and other bits that are optional, right? You see that in a lot of different popular libraries. That's really, really good, because now the user is able to select what they need and what they don't need. So I think that's a really, really good model. And the thing I'm thinking about for 4 is actually the thought I had was a Dunder API that would sort of supersede Dunder all, and a new import mechanism, a new packaging mechanism, where you would be able to declare Dunder API on classes, on functions, on modules, and then you would then be able to actually import from APIs, and then packages would be able to explicitly represent what version of a class, what version of a function should be here and there and the other. So that's kind of the high-level thought. But anyway, that's, yes, please put more things in. If you have a popular library in particular, to the best of your ability, factor out the common data bits that are likely to be stable over a long period of time from a lot of the function bits that are likely to change over time.
So Thank you very much. This is a great talk, and this is a dimension of the packaging question that I feel like the community has yet to internalize. But my question for you is, I feel like, as you cited Mahmoud Hashemi's talk quite extensively, we're kind of stuck in this conversation because we don't have the language for separating out these, in some cases, totally separate dimensions of the packaging conversation. Like bundling for deployment to end user mobile devices, for example, is like not even the same kind of thing at all as shipping a library that can be installed on PyPI, even though they're parts of a similar toolchain. So, but yet we still call it all packaging, right?
Yeah.
Like these are still just packaging. Do you have any thoughts about popularizing language that could help us sort of start to separate out these communities with very different interests?
Yeah, I think the way I've thought about it is that it actually goes back to the thing I had in a little sub-bullet on number 3. Let's see if I can get back there. And that is this idea that Python doesn't have apps. And the sub-bullet here, I think, is the real $10,000 thing, or whatever, $64,000 thing. And that's that the Python community, I think, is overly fixated on the interpreter itself. And what I mean by that is that we start by saying, well, what is your system Python, or what is the Python you have? And if you actually were to turn this around and say, I don't care, you'll get a Python, we'll get you the Python you need, what's the thing you want to do, right? And that actually takes that, and this is not because I don't like the CPython team or think there's anything wrong with CPython, it's more just about the paradigm of how we think about what it means to use Python to build a thing and then to share that thing with someone else. And so I think the conversation would be, what we have to do, I agree, I mean, to take the spirit of your question, yes, I think we need language. I think we need new language around this. And I think that language needs to focus more on what are you trying to do with Python? And what does that whole thing look like? And then here are the right bits and pieces to do for it. And hopefully, most of it does not involve shipping your entire SDK dev environment off to the deployment thing, because that's generally not actually what you want. It's just kind of what everyone does, right? And so if we do that, then we're able to look at a bunch of these different things and say, okay, yeah, a lot of these problems actually clarify, because then the actual workflow is different. But this requires an upgrade of our conversational sense-making ability as a Python community to actually take a very product-oriented, a product management-centric sort of view on this, right? What is the user workflow? What are they trying to ship? What are they trying to deploy? And then start from there, instead of just saying, well, what's a package? And here's the interpreter they've got, and we'll just do these things and throw in a Docker, right? And so that's kind of I think that's kind of where we have to move to for this language to actually get through this.
Thank you very much.
Hi, thank you so much for coming. I am so excited about this talk. And I think that the vow of poverty one, of the
Which one?
The last Demon 6, the vow of poverty one, is one of the more kind of like sneaky ones, because so like historically coming from like the startup space, the open source contributions have outlasted the companies themselves. So the companies that seemed so big and so stable and so in charge of everything basically have disappeared, and then the frameworks and technologies and such that they have left to the open source community that were really valuable outside of those things in other contexts then just outlived the existing companies. So I think part of the suspicion is because of that instability that has been historically there. When we've crossed that like chasm into like mainstream, basically, is it possible that that instability will go away at some point in time, and thus change the reputation of relying on these companies for these kinds of things?
I think there are no guarantees in life, right? And it is entirely possible to open source the wrong way. And so, having said both those things, it is also possible to open source the right way, I think, right? And so, the dynamic you're talking about, it's absolutely a real one, that there's a matter of trust, right? And I think that's and I don't also want to, on this thread, like I don't want to, where was it? Here, I don't want to call out anyone who is participating on this thread, because I think it's coming from a good place. It is exactly what you're talking about, which is, as a community, our values are, technical merit and sustainability and openness to contribution, openness to innovation, all these things. And in general, most people's experience of like hyper-capitalistic, sort of venture-funded kind of things, they don't manifest any of those values. They do not give a rip about any of those things. If you got good software on the outside of it, great. That's like, cherry on top. So I can absolutely understand how when we articulate these things, it's coming from, if I'm going to steelman this, I would say, it's coming from a place of expressing that we don't trust that the stuff being built out of this value system can actually be in integrity with what we hold as values for our open community here. And for people who want to hear more of my thoughts on this, because you haven't heard enough of me today, I gave a talk at PyData Berlin, or PyCon DE, in, I think, 2019. It was a keynote talk about the human ecology of open source and what is software itself. And actually, the thing to keep in mind is when you're talking about, oh, the software gets left behind and it outlasts the company that made it, software isn't actually just a zip file and some code. Software is actually a dynamic human ecology. It's an ongoing thing. So it's actually more about the people in the project than it is about the code. And my metaphor there was, it's the difference between the Mississippi River and a scoop of water out of the Mississippi River, right? So that's your tarball, that's your release, right? But the actual river is actually this dynamic of a thing that keeps going. So if we actually go and we say, intentionally with eyes wide open, we say we want to build companies, we want to encourage the development of projects that have this living flow through them, that engage the human ecology of open source and the open source ecosystem, making money. If you put a mill wheel on the side and it's generating energy and revenue, that's great, go nuts. But what you don't want to do is like cut off the flow or drain the river, right? So I think if we have these kinds of conversations that are, again, more in depth about what is it we're really trying to do, what is it we're really trying to prevent against, then we'll have a much more mature conversation than, oh, well, he raised some VC money, whatever. Like we raised some VC money and we've put $30 million into the open source ecosystem, right? We maintain Jupyter Notebook Classic right now. We are able to do these things because we're trying to build business models that can actually go and keep that kind of sustainable and meet the values and the needs of our enterprise users as well and customers as well as the open source community. So long answer to a very simple question, but it ultimately does come down to this question of us as a community being able to talk about our values and talk about what we want to see. Make sense?
Any more questions?
One more question.
Great talk, thank you. So for those who remember in the 80s and 90s, Microsoft and other software vendors, they would just release at random times Windows 3.1 based on functionality. And then that's settled, in my opinion, now they release once a year or even between multiple years. Mm-hmm. Do you see any place for that in the open source community? Like I know you have this Anaconda premium feature thing, but that all of us together, like we could ship all our open source packages and pin our versions for like Python 2025, and like if you want to be in this bundle, have you thought of that, or do you see any place for that?
Yes, so that's a great concept. That right now a lot of the to state your question a little bit differently, some of the churn that we get comes from the fact that everyone's releasing at different times, and so there's not a single time to like freeze the world, make sure everything works, and then release, right? And there are language communities that do this in a sense. The R community, famously CRAN, right? The public repository of R packages, they sort of do nightly snapshots. And so if you, and they also require everyone to test all their builds before it gets actually checked in and approved by CRAN. So there's some gatekeeping there and whatnot, but at the end of the day, you are going to run against a particular nightly tag or particular date for the CRAN repo. God forbid you want to go back 2 years in time, right? Good luck. Or you want to cherry pick a little bit. The problem's not solved. So I think in our community where we have 100,000 packages, 200,000 packages on PyPI, lots of people with internal builds that they do at the big banks and all these other companies, everyone's got their own fork of the Python interpreter. That is really, really hard to do at scale for the community. However, that being said, there's absolutely value in having a rationalized, coherent distribution that is long-term stable, an LTS, long-term supported distribution, and that is something we've looked into doing at Anaconda, like in particular to support our partners. So you think about what just happened with our Python and Excel release. We cut a version of the Anaconda distro for Microsoft to run to back the Excel computation. Guess what we're not doing? We're not updating random packages in there every single day, right? There's a version of it, and that's what it is. And so I do think there is absolutely room for that. And additionally, back to the question about the business model, the previous one, as end users, we care a lot about innovation. We care about getting people the latest kind of stuff, the bug fixes, the security fixes. We don't actually particularly love maintaining stuff that's 3 years old. We don't particularly love backporting stuff to Python 3.8, okay? Those are the things that some businesses do need, however. And I think if as a community we said, wait, that's totally valid to sell the maintenance on this stuff, then great. Then it's like win-win-win, right? So I think that's the kind of thing that we should be, more open to talking about as a community.